and our goal was to improve Sanskrit generation in open source models. Next slide, please. So the problem that we faced while generating Sanskrit responses were we were often getting incomplete responses and amalgamation with the languages which follow the same language script Devanagari, which is like Marathi and Hindi. This is the result because the result is achieved because we these LLMs are not being pre-trained on Sanskrit specifically, and they might have been like less than 1% of the whole dataset it has been trained on. We also noticed that popular LLM tokenizers are predominantly trained on web data and are inefficient at representing the Sanskrit language. Next slide, please. So we started off with choosing the right LLM for the experiment. So we selected AI, Llama, and Gemma models for evaluating it on language detection, cosine similarity, blue score, and rue score. So for language detection part, we use Meta's fast text model for language classification. And based on the results, we selected Llama 3.18b and Gemma 2.9b for fine tuning. Next slide, please. So before moving on to fine tuning, we thought of using these prompt strategies to get the best out of these models. Hence, we implemented zero shot, five shot, and self reflection on these models. However, we could not get a good improvement on these methods. So we moved on to fine tuning. Next slide, please. Yes. We decided to fine tune these SLMs on translation and question answering tasks. Uh, we had a good quality of dataset for translation. Hence, it was easy for us to fine tune SLMs on Sanskrit data. However, that was not the case for question and answering. Hence, we had to generate synthetic data for it. For synthetic data, we used the corpus that we had collected, which was just Sanskrit text, and we fed it to a teacher LLM that was Llama 70B, and we generated some 11,000 question answer after thorough filtering and data cleaning. Next slide, please. Yeah, and these were the results. So I'm happy that we got good improvement over fine tuning for translation task over blue score, cosine similarity, and rue score, and we got a quite satisfactory result on question answering task that we had conducted. Next slide, please. Yes, talking about the tokenizer approach. So I just mentioned before how inefficient the tokenizers are for Sanskrit generation, and here we thought of a good approach to improve that. So there is always a trade-off between the vocabulary size and the token length, where both the thing has to be balanced properly. So we thought of dividing the Sanskrit text into nouns, verbs, and the other morphemes. In this case, the nouns have infinite numbers in the language space. So we thought of going forward with VP tokenization for it, so that it will tokenize nouns sub-optimally. For verbs and other morphemes that we have, they are pretty exhaustive in the language space. So we did word tokenization for that. And here in the image, you can see how the graph of graphemes versus the token count is there. So in this case, the Indic languages like Hindi, which follow the same script as the Sanskrit, have much more amount of token count for grapheme count. So next slide, please. Yes, so that was our work for 6 weeks. We would, in future, we would like to start crowdsourcing for good quality of data sets. Since Sanskrit is a low resource language, we could do only this much in 6 weeks. So using this good quality of data set, we would further continuously pre-train these SLMs and fine-tune these SLMs on specific domains like textbooks where students would, it would be easy for students to learn from that. We'd also like to develop better evaluation benchmarks so that we can evaluate these models better, and also enhance the NLP tools so that we can support our tokenization scheme. Next slide, please. So that's it from our side. You can check out our recipes, datasets, and models on Hugging Face and GitHub repository. Also, you can reach out to us on Twitter. And thank you so much, Courier AI team, for giving us the opportunity to showcase our work.
Thank you